When the Earth's thermostat breaks, it has dramatic consequences, like the entire planet freezing over.
We're talking cold like you've probably never experienced. Temperatures at the equator as low as negative 43 degrees Celsius, and perhaps even plunging to negative 130 degrees Celsius at the poles. For millions of years, people. So cold. So very cold.
How do we know all this, you ask?
Well, the evidence of this icy past surrounds us, probably even in places that you visited on your favorite summer getaways. Let's explore and find out more. Picture a world where the equator resembled the Arctic, with ice sheets covering land and sea, glaciers shaping the landscape right outside your front door.
Sounds like science fiction, but it's the mind-blowing reality of Earth's history.
This phenomenon, known as Snowball Earth, occurred at least twice during the period of geologic time known as the Cryogenium, which lasted from about 720 to 635 million years ago. And guess what? The proof? It's in the rocks.
It's literally set in stone. Wait, was it an asteroid that did this? I feel like it's often asteroids.
True, it's possible that one may have helped chill things out during Snowball Earth, but the main culprit was right under our feet, or the proto-feet of whatever insanely sturdy creatures were living on this planet 720 million years ago in this deep freeze.
Maybe an adit? We're talking about the carbon cycle, our planet's thermostat. It broke, sending Earth into a deep freeze. Here's how.
The carbon cycle regulates Earth's temperature by balancing carbon between the atmosphere and our planet's crust.
Imagine this. Volcanic eruption sending CO2 into the atmosphere. Gradually over thousands of millions of years, our planet stays warm and cozy.
But too much CO2 and things can overheat. So Earth stores it in carbonate rocks through the process known as weathering.
More CO2, more CO2.
Too hot, too hot, too hot, too hot.
Less CO2, less CO2.
Oh, cold, 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 cold.
Just enough CO2.
That's perfectly right.
However, during the Cryogenian, the breakup of supercontinent Rodinia changed everything.
Now, this was a very bad breakup that released vast amounts of basalt, which just absorbs CO2 like a sponge.
Plus, Rodinia was the equator, a warm, wet region, accelerating weathering.
So this imbalance led Earth to store CO2 faster than volcanoes could replenish it, eventually chilling the planet enough for ice to form.
And that's when things really got bad. Once the ice began, it set off a chill cycle. Ice reflects more light than water, keeping things cooler, and making even more ice, and so on and so forth. A runaway refrigerator effect.
And as it turns out, it's not that easy to catch a runaway refrigerator. Who knew? Once ice-covered areas beyond 30 degrees latitude, an area that on modern-day Earth includes desert landscapes in places like Big Bend National Park, the ice was basically unstoppable, and it just took over the world, covering it in ice for about 50 million years during the first snowball period and about 10 to 15 million years in the second.
How do we know all this? The rocks tell the story in the form of dropstones as evidence, because ice does not burn ice.
Oh no, sure, ice may look all quiet and still and peaceful in your local neighborhood pond, but don't trust it, because that ice is an earth-changing bulldozer, crusher, destroyer of worlds, people. The rocks know what I am talking about.
What Mom's trying to say is that ice is a powerful force that can reshape continents and move mountains.
That, yes. Ice. Ice is the solid state of water on our planet, but it's not nearly as hard as rock. So the force of gravity on a large ice mass causes it to flow under the pressure of its own weight. It shapes the Earth as it moves, and this is why we find evidence for Snowball Earth on every continent on this planet in the form of dropstones.
These dropstones were carried by glaciers, moving around and then deposited once the ice melted, leaving behind clues.
Like little wayfinders, these dropstones record the direction of the North Pole at the time they were deposited in the sediment that builds up around them. And so this paleomagnetic record provides evidence supporting their movement via glaciers. And here's where I have to admit that the term dropstone sounds sort of quaint, like a little pebble that gets stuck in your shoe. But these glaciers were epic earth movers. In fact, it's possible that the Snowball Earth glacial event carved away the top 3 miles of rock from our planet, people, effectively removing up to 1 billion years of geological time from the rock record. Gone. Is that geological time?
No, that's pizzazz.
Because
Glaciers have pizzazz and rocks have pizzazz.
pizzazz.
And you can see this missing rock at one of your favorite summer vacation destinations.
We call this particular band of missing rock the Great Unconformity. It was first identified by John Wesley Powell and then named by geologist Clarence Dutton in 1882 as they explored the area we now call Grand Canyon National Park. And millions of visitors like us can view the impact of Snowball Earth in this very unconformity every year when they stand looking out over the south rim of the Grand Canyon. And they may not even realize it.
While spectacular to see, the Grand Canyon isn't the only location you can find this unconformity.
It spans the continent, and you can find similar unconformities across the globe, suggesting something removed a whole lot of rock from our Precambrian world. And the most likely explanation is that the glaciers of Snowball Earth just scraped all that rock away, eventually depositing it all in the oceans when all that ice melted.
How did the ice melt anyway,
Well, it all comes back to carbon dioxide. Rodinia's breakup led to more volcanoes, releasing CO2 back into the atmosphere.
However, with the planet covered in ice, there wasn't enough rock exposed to capture the CO2. Our planet's weathering system was basically turned off.
So eventually, rising CO2 levels warmed the planet, perhaps quickly, melting all that ice. And all this set the stage for life that somehow survived this brutal, frozen world to explode into the wonderful descendants of Snowball Earth, like you. What's your favorite wacky descendant of Snowball Earth? Tell us in the comments below.
Mine is the freezer, where we keep the ice cream.
Ice cream sounds good. Okay, you can come back now.
Hi, camera.
Try not to destroy the studio while you run away, refrigerator.